The interop between CADWorx and PVLeet is bidirectional. So modeling can be done in either PVLeet or CADWorx. An analysis and final modeling will be done in PVLeet. In this case, you can run the full analysis to check on your vessel to make sure you have adequate thickness and your nozzles are good to go. Maybe you need to put a stiffening ring on there, or perhaps some other details. And there's no need for a translator at all. CADWorx can both import and export a native PVLeet file. That's a PVDB file. And so the benefit of this is that it reduces man hours by not duplicating modeling of the vessel. So the last thing that you want is to have somebody create a vessel in CADWorx and then also have to create it in PVLeet. No, in this case, PVLeet and CADWorx work really well together, and you can import the file in seconds and reduce all that time wasted. So let's check it out. CADWorx equipment will be the area in which you can create a vessel and export to PVLeet. This is the central hub for PVLeet CADWorx Interop. A variety of vessels can be designed, including both horizontal and vertical vessels. Components are added one by one. These components can be large elements like heads and cylinders, or detailed components like nozzles, stiffening rings, saddles, and more. All component properties can be further specified to address material, overall geometry, thickness, layout, orientation, and more. In this case here, we have a relatively simple horizontal vessel, with just two heads and a central shell on some saddles. However, the workflow is going to be exactly the same no matter how complex the model. Simply export as a native PVLeet file using the export feature located within CADWorx. This newly created file can be opened up directly into PVLeet as shown. In PVLeet, users can edit the model as they see fit, perhaps by increasing the thickness as shown. After running the full analysis, the conclusion was made that a repad was needed for this nozzle on top of the vessel, a simple task in PVLeet. The nozzle was also repositioned on top of the vessel. After these changes are made by the PVLeet user and saved, the newly saved and updated model can be opened easily in CADWorx equipment. Now we see a workflow that begins in PVLeet. Here, a vertical vessel with a bit more complexity is created from scratch. This is a vertical tower sitting on a skirt with a base ring. Some more details like a cone-to-shell stiffening ring and nozzle on the top of the vessel are placed. These are all details that CADWorx will be able to recognize and import with ease. Seeing both sides of this workflow is important because it shows that the same goal of having a built vessel within the CADWorx environment can be achieved in multiple ways. So whichever method is preferred by users can be taken. Here we can see the vertical vessel being imported into CADWorx equipment. Again, this is the native file that is created in PVLeet. No need for any translator. Note the stiffening ring detail and nozzle on top head.